Hello everybody. I know that we have quite a few schedule changes and some people were not here for the lesson yesterday, so I'm going to do a quick review. You can also use this for today's assignment, okay? Now, your whole objective here is to figure out what's an element, what's a compound, a mixture, and what type of mixture you have. Okay, so remember, if something's on the periodic table and it's by itself, like aluminum, this is an element, and that's it. An element is your smallest part of matter. Now, if you have two elements or more, like baking soda or salt, this is a compound. So any two elements on that periodic table coming together is a compound. Now, if I have a mixture, I can have something like water. And let's say I mix a little bit of salt in there. Both of these separately are pure substances because water's a compound, you have H2O, you have two elements or more. Sodium's a compound, you have NaCl. Both of these are pure substances. But when I put the two compounds together, this now becomes a mixture. Okay? So now, because the salt is going to dissolve in the actual water, this is a homogeneous mixture. So remember, homogeneous mixture, another name for that is called solution. So that means that the top, the middle, and the bottom are all the same. For example, a cup of soda. So if I give everyone a little bit of soda in each cup will taste the same because the top part, the middle part, and the bottom part are going to all be the same. That's a homogeneous mixture, a solution. Okay, now, if I have two compounds or more, kind of like water, and let's say, let's put the water in here. And sand is a mixture as well. If it can be separated physically, or you can do something like evaporation or something like that, and it separates out. For example, oil and water do not mix. Okay, so here you see how it's settling on the bottom, some part is in the middle. This is a heterogeneous mixture, okay, because it's separate. Also, if I put oil or water or syrup and milk, they're going to separate. That's a heterogeneous mixture. Okay, even something like a bag of M&Ms, because you have different amounts, you can separate into different parts. That's a heterogeneous mixture. Okay, all right, let's say difference between chemical reaction and physical reaction. Here, when I dissolved the salt in water, this solution, it's just a physical change. It didn't change any of the chemistry. It just dissolved. Dissolving is a physical property. If I put this on a hot plate and evaporate the water and the salt will stay in here, it physically separates. That's just a physical change. But if I have something like this, a little vinegar, and let's put a little bit of baking soda in there. The gas that's going on here, this is a chemical change, okay? So when nothing changes chemically, this is physical, and this is not only a physical change mixture, but it's a homogeneous mixture, okay? Here, also, you're having a chemical reaction because you can see the gas bubbles as well. It's chemically changing to a different substance. You're going to have carbon dioxide and water. Okay, this is a chemical change. So chemical change, physical change, homogeneous mixture, or something like juice or soda, homogeneous mixture, and then heterogeneous mixture. Okay, remember, two elements or more is a compound, and one element by itself is just an element. That's your smallest part of matter. Okay, and that's it. What you're going to do today is a little review of what we did yesterday. And so on your worksheet, you're going to check mark whether it's homogeneous or heterogeneous. So let's do number 1 first. You have flat soda. So just a soda can. Is that going to separate, or is it going to all be the same? It's going to be all the same, so it's a homogeneous mixture. You're going to check mark the homogeneous. Okay? For your